Welcome to Samuel Academy. In this video, I want to explain how we can use the principle of moments to do some computations. In this system, we have our various forces and distances. Okay, so we are looking at the turning effect of a force, especially when one of the forces is inclined at an angle to the horizontal. Right? So we have this weight, 20 newtons, acting at this point, x units away from the turning point, the pivot. We have another weight here, 80 newtons, acting vertically downwards, 10 centimeters away from the turning point, the pivot. Then we have this force that is acting vertically downwards. That is the vertical component of the force in the pulley system. So we don't have this force, we shall have to determine it. Let's see how we can proceed. So we see that the force in the pulley system is inclined at some angle, 30 degrees to the horizontal. This 180, this was given as 150, so this must be 30 degrees. And the force is 15 newtons. So you want to go ahead and find the vertical component of this force. The weight, the force which is acting vertically downwards, because that's what we need. So we are talking about resolution of forces. So that force in the pulley system can be resolved into its vertical and horizontal components. Let's consider a right angle triangle whereby this is the force in the pulley system. It has the vertical component and the horizontal component. Using trigonometry, we realize that the sine of this angle is equal to the opposite side over the hypotenuse. The opposite side is actually the vertical component of this force, that is Fy. The hypotenuse is this force. So sine 30 degrees is equal to Fy divided by F. And from here, we can find Fy, that is the vertical component of this force, which is equal to F times sine of 30 degrees. We found that it is 15 newtons times 0.5. This 15 newtons is the force in the pulley system. So you multiply by the sine of the angle 30 degrees, we get 7.5 newtons. So we are interested in the vertical component, not the horizontal component. Otherwise, this is how you'll get the horizontal component. The cosine of angle 30 degrees equal to the adjacent side divided by the hypotenuse. Okay. And if you want to get the tangent of this angle, it is equal to the opposite side divided by the adjacent side. So this is how we can get the vertical component of this force, Fy, which is 7.5 newtons. Now in this case, we are going to use the principle of moments to be able to determine this value x, this distance from here to here. Okay, because we are calculating the moments about this point, the pivot, in the anti-clockwise direction and the clockwise direction. So the principle says that the sum of anti-clockwise moments about a point is equal to the sum of clockwise moments about the same point in a situation whereby there is a balance of the forces. Right? So in this case, the anti-clockwise moments is equal to this weight, 20 newtons, times the perpendicular distance x, that is 20x, is equal to the sum of the clockwise moments. That is this weight, 80 newtons, times this distance, 0.10 meters. 8 times 0.1 plus this weight, the vertical component of that force we talked about, 7.5 newtons, times this distance from here to here, which is 0.15 meters. Because this is 0.1 meters, this is 0.05 meters. So it is this weight times the perpendicular distance from here to here to the turning point, the pivot. So we get this time this is 0.8 plus this time this you get that. Then the sum of this you get 1.925. So to get x here, you divide this side by 20, you find that it is 0.09625 meters or 9.625 centimeters. So that's how you can use the principle of moments to calculate whatever item that is missing in that system. And we have seen also how we can resolve forces, okay? How we can find the vertical and horizontal components of a force when the force that is acting at an angle. Thank you so much. I hope you have found this video helpful. So kindly subscribe to see more videos in physics. Thank you.